Good morning, everyone. Welcome into the OSG Garage today. We're going to work today on one of my a little more rarer bikes. Montesas are pretty much all rare to begin with, but the one we're going to work on today is this 1975 VA 125 Cappra. This is kind of the second generation of Montesa motocross bikes. Came out in 1975. It's still a port induction motor. It has no reeds, but it does have a 6-speed transmission. It has a little bit more suspension travel, but it's still not kind of the late 70s bikes like the RMs and the YZs, you know, on that par. But it is a little bit more updated than the original 125 MX Cappra, which was in the early 70s. That was only a 4-speed bike. This thing does have a 6-speed transmission. Still, we got drum brakes, still 35mm forks, but a little bit more travel. But it's pretty much still in that classic Montesa with the fiberglass tank. It still looks in that same vein as the bikes that they originally produced. It's pretty much a survivor. The tank still has the original stickers on it, original paint job, original side stripe stickers. There's pretty much nothing been done to it. Original fenders. Now they get a little yellowed over time. I believe these are like a nylon. I don't think they're polyurethane. They might be polyurethane. I'm not sure. Or polypropylene, excuse me. But the engraved or molded in logos are pretty good on them. So for now I'm going to leave them. It has the original front number plate. This front number plate is just kind of clipped on, as you can see. But this is kind of something that the bike would have had when it was brand new. So I don't think this bike was ever raced because it has no side plates on it. Again, it's got all the original stickers on it. It's pretty cool. I do plan on racing this thing in vintage, post-vintage racing in the AHRMA, which is American Historic Racing Motorcycle Association. And this bike is post-vintage because it's after 1975. Plus it has a 6-speed transmission and a few other things that keep it into that class. Now, in AHRMA, you have to have a yellow backing plate for your numbers. So I think what I'm going to do for this bike, I got some of these yellow number plates. I'm just going to mount them through the original screw holes along with some factory backing numbers. This is my number I have to run. And we're just going to kind of screw them into the original holes here. Maybe just put one more hole so I don't mess up the look of this original side plate. Same thing on the front. I'm not just going to take this number and paste it onto the original front number plate. I'm going to mount a new number plate here with the factory backing graphics so I can keep all those originals. I also have some modern Renthal bars I'm going to put on here. These are steel bars. They're okay, but I like the bend of the Renthals, and I also have them on my Cappra 125 MX, and I really like the bends. The original ignition on it, which was the electronic motoplat, it wasn't producing enough spark. It really wouldn't turn over. So I swapped out a HPI electronic ignition, and we got that all updated. And once I got the timing and everything right on it, this thing fired pretty much right up. I did put a 32mm Mikuni in it, which gives you a little bit more flexibility for tuning than the original Amel concentric that came on the Carb. Now, it was a little bit rough. It needed a few parts. I could get the parts from some of the places over in Europe, whether In Motion or some of the other Spanish suppliers. But I decided to go with the Mikuni because I've got jets, complete set of jets. It's the same jets that run on the 28s that I run on some of my other bikes. And it's just something I know. We updated the petcock, and that's pretty much it. We do need to put some new fork seals in it. Fork seals are pretty much gone. They're still pretty similar, stock 35mm fork seals. So we'll get that updated maybe in another video. For today though, what we're going to focus on is in the air box here. I don't know if you can see it, but there's a gap between the carb and the carb air box. And that's because the 32 millimeter Mikuni has a bigger spout on it, or smaller spout on it than the other carburetor that was on here. So we're going to take the air boot. Here it is. Here's the air boot that came on the box. And there's a couple things we can do to it to make this thing work with the existing carb. Basically, I can just make a little spacer on the inside, whether it's rubber or something else, and then just clamp it down on the carb, and that should work. That's one option. I don't want to cut this up or do anything to it to modify it because it's a pretty, I wouldn't say rare piece, but they're not exactly easy to get a hold of. Now, another option I have is I have a Creality 3D scanner and a printer, and I can print in TPU, thermoplastic urethane. And the TPU material works pretty good for carb boots. All right, so one thing that was always something in the shop, anytime we want to do some work on a bike and we want to put it on the lift, we always have to deal with this junk. A flat surface attracts stuff. It just always works out that way. So I'm going to go get that cleaned off. We're going to pull the bike up on there, and I'll take the side plates off, and I'll show you what that airbox looks like. All right, so we got the bike up on the stand, and we got a couple 10 millimeter bolts here to take off. I think these are some threaded inserts in the frame from what I remember. So we're going to grab a 10 millimeter. And let's see. Yep, they just come right off. Could probably, oh, I guess not. Seem to be actual nuts. Let's take this. Nope, they are threaded. So you can see the threaded inserts there. Dropping stuff all over. Here it looks like we've got a couple of Phillips head screws. Screwdriver for that. And I think we have the same threaded screws on there. Thread inserts, I should say. Like little clips. Frame clips that are threaded, which makes it easy. You don't have to hold the back. And there we are. All right, so now that I know that I have to make the hole in the gasket bigger, what I think we're going to do is we're just going to recreate it in CAD. It's a pretty simple design. Everything's round. I'll just take my calipers and recreate what's there. But a couple dimensions I need to get off of here. I want to double check the distance from the front of this face here to the edge of the carb spigot here, just so I can see how long to make the protrusion here. We'll also check the ID of this carb right here, OD of the carb right here, excuse me. And then on this piece here, the opening here is like a V shape. I'll show you that on the part, but I want to make sure I got that dimension as well too. So let's get this, so slide this out, and we'll take a couple dimensions with the caliper. Check our calipers are 0, they are. Slide this open. Looks like this is 2 inches. We'll call it 830. 2.830 is what we get on this. Now the diameter of the carb I can look up, but as long as I got this, we'll double check it with the caliper as well. And that is just a little over 2¼ inches. All right, so with those 2 dimensions, we'll go back upstairs, we'll get on Fusion 360, and we'll draw this thing up. All right, so let's take you into the process of this. We've got this part and we want to recreate it. One way you could do this is by taking a 3D scanner, which I happen to have. I have a Creality scanner here. And I did try taking some scans of this part, but the problem is the scanner doesn't have the resolution to get in there to establish all of these little crevices and details in there. So it wasn't coming out really well, and frankly I'm not really skilled in using the scanner yet and transferring it into CAD. Now the CAD I'm using is Fusion 360, and it's the free version of it. You can go online and check it out, how you can use the free version. It's got a few less features, but for what we're doing it's going to be perfect. So basically I'm going to take this part here and use a pair of calipers and get some dimensions off it, get some outside diameters, some IDs of this, maybe check some of these heights, size of these things, and I'm going to make up a little sketch. And so we're going to basically kind of make a little sketch of what the part kind of looks like. And then we'll attach some dimensions to it from the CAD. Now I know, for instance, the ID of the spout here on my carburetor is 2.250 inches diameter. That's the spigot that's on the 32 millimeter Mikuni. That's what we're trying to seal to. So some of the other things we want to check are like the overall dimension here. It's 3.8. So we write down some of these numbers, 3.80 inches. Then we'll check the heights and whatnot and get a kind of complete picture of it here. So once we have kind of an idea of what we want to do, we'll come over here to CAD, and the first thing you start with on these things is called a sketch. And the way the sketch works is it's basically, let me get my other mouse. This is the kind of cross section that I drew that I want to come up with. Now the part that's here on the bottom of it, I might need for stability and support when I build it, and then I'll cut it off. But the idea is you make this sketch and then drive it in a circle 360 degrees around an axis, and that's what gives you the shape of your part. And this is one of the parts, this is where I'm going to start with this part. Now from here, you save this part as what's called an STL file, or a stereolithography file. And that's the kind of part you use for most 3D printing software. So we take this part, we saved it, and we'll drop it onto this little plate here. This software here is called Orca, and this is a slicer program. And what it does is it takes the part and basically puts it in a language that my 3D printer can understand. Okay, so we kind of orient the part the way we want it. I put the surface down. This is the way we want to build it. You come up here and basically say slice plate. And now what it's done is a few other things you have to tell it. You have to tell it how many slices you want, 0.2 millimeters, etc. The thickness of the slices. You have to tell it the material it is, because it has different settings for build speed and temperature. But simply, it basically just slices this part starting at the very bottom layer, and it slices it into pieces that the printer can understand and know where to move in the XY position. And from there, we take a memory stick, we'll load this program onto a memory stick, and then we'll head over to the 3D printer. All right, what you're looking at here is a Creality printer. This printer is the K1 3D printer. And I've been using it a lot for a ton of different things. It prints lots of different materials, flexible materials like TPU, PLAs, PETG, carbon-filled PETG. It's really a good printer. It's also extremely easy to use. That's what I like about it. I basically plugged it in and went, and really haven't had any issues. So the first thing we do to start printing this thing is we find out where the print is. We've got to find the Carb boot on the little memory stick I put in. Basically just hit it and say print, and that's it. I already have the material loaded in, and I know the print bed is as clean as I want to get it for right now. So we'll let it do its thing, and we'll check back when it starts printing. So now it's laying down the first few layers, maybe some support layers. These first few layers are pretty important because this is what attaches it to that build plate. And every 0.2 millimeters, this build plate will move down, and it'll build another level on top, and it'll just keep doing that until the whole part is formed. We'll check back in on it in a little bit. and slowly it just keeps building it up until it's all done. Pretty cool, huh? Yeah, 3D printer. I use it a lot more than I thought I would, that's for sure. So the 3D printing phase is done. And as you can see, we've had a few what I would call iterations. Sometimes when you get into this stuff, especially with me, I tend to just make some prints, make some designs, print it and see how it fits, rather than just taking the time to really understand how it works. What basically happened here is on this particular part, this is the original part. It looks like it was compression molded out of rubber or some type of urethane. The very thin bead on the inside of it is designed where it only works if it's smooth and if it's plastic. My first try at it on the 3D printed part, it just wouldn't fit. It's not flexible enough, the material didn't work. So we started changing and playing with that. Actually, the very first one, let me just fess up here. I measured the wrong hole on my first sketch. There's this hole in the back of the air box here that I measured, which is basically brings air into the filter system. Why I should have been on this one. So that was the first mistake. Anyway, through different iterations, we got something that fits, and we made the part up here. So what we're going to do is we're going to pop this in the air box, and we'll slide this in there, and we'll go mount it up on the bike, and we'll see what that looks like. I think the takeaway here is when you're designing something in CAD and trying to mimic an existing design, be patient, take a little bit more time. You might have to print a few different versions of it to get exactly the fit that you want, but it's worth it. I did have to thicken the wall stock up on this a little bit too. I originally went with a little bit thinner wall, and I thickened it up just to make the part feel a little better. All right, so we've got the part here, we've got the airbox slipped in. I think what I'm gonna do is I've got a hose clamp right here that has to fit up around this in order to seal off on the carb spigot. So let's get that up in there, and we'll just try to slide this on. Now, a challenge we might have with this is sliding this over the spigot. So I might need to get some, I might need to have two hands for this. So just give me a second here, and I'll get that carb spigot to fit on there. All right, we've got the spacer, the carb boot is in, fits over the spigot. Now I've got to unthread that clamp, thread it back in, but you can see on the inside, everything looks to be well lined up. And I just put these screws back in here to mount the airbox, and we'll put the side panel on. All right, so now with this mounted, we're going to put the 3 screws in to secure the airbox to the frame, and then we'll put the side panel on. So the screws are in. Now let's see if we can't, what I have here is I took an existing filter I found on the shelf, and this particular filter style is through, and it has a cap on the top. It's a little bit older, so it just uses the OD of the filter. So we're going to slide this in here somehow, like that. Now, typically what I would do is put some grease or oil on this bottom sealing surface, but for now, all I'm trying to do is just get this thing buttoned up. I'll come back later and make sure that the filters are oiled and everything, but that's how this thing will sit inside of here. Just got to get a little 10mm nut, and we're good to go. I realize I said 10mm nut. What I meant was a nut that'll fit with a 10mm wrench, so which is a 6mm. Put this down for a second and get this screw started on the back there. All right, well, the airbox is all booted up. Got our new carb boot on it there. It looks really nice. Everything looks good. The airbox is in. One other thing you might have seen on this bike, if those of you noticed, I did have some new DC Plastics reproduction fenders. And I'm going to put them on the bike for now, even though I have the originals. I just don't want to get the originals cracked in half. If I ever do go back and want to keep this bike original, they'll be a nice touch to put the originals on. I do have, but these will wear a little bit better. The other ones are very brittle after years and years and years. So I got these guys mounted on. And also, you can see I started this one number plate here on the side using the existing side cover screw. And as you can see, I got to put another screw or something in there to keep it from twisting. I'm thinking of putting one more screw in here just so it doesn't turn. I did a similar way of mounting these on my Cappra 125MX, and it worked out pretty good. So let's put this camera down, and we'll go ahead and mount up this one on this side. So basically, we'll attach the side plate, which actually this is the airbox cover, and you can see I've got two holes here and here, and the new plate is large enough so that both holes, you can see it's yellow there and yellow there, will be covered. So all I need to do is get this thing oriented properly so the graphics are flush. I'll mark the hole from behind with a marker, and that's where I'll drill a little pilot hole, and we're good to go. All right, so I drilled holes in here in the clearance holes, and they should line up with the holes that are on this on the plate here. So pop those through. Not sure if I really like the look of the screws coming through, but you got to have a little compromise somewhere. So we'll put this one in here first. We'll get it started. Get that started. Nice. I've got another washer and lock nut on this one. This one down here. Nice. Lines up pretty good there. And then the last one is up here in the top. Again, we'll put a lock washer and a washer. It's probably a little overkill, but it'll work. And I'll cut that screw down later. All right. All right. We'll screw these in. Yeah, I might change those screws. They stick out a little bit. I'm worried about my boot catching on that. Might go to like a lower profile pan head screw. But I think for now, that's going to do it. Everything's all mounted up. It looks pretty good. Nice. And on the front, here on the front, I already have this mounted too, as you can see. But what I did is I printed some standoffs here in the 3D printer and then screwed them in with some small screws. And then I put the sticker over everything so you can't see it. This thing isn't going to have to come on and off a lot. And if it does, I'll just snap off these wire ties that are holding it on. So that'll work out pretty good. Awesome. Well, I got to say, I really like the look. And the airbox and side plates are done. Well, everybody, I think that's going to do it today for the VA build on the OSG Garage. I think we're going to show you in a separate video coming up next. We'll show you forks. We'll show you changing out some bars, as well as putting new tires on the bike. So that'll be in the next video we put out next. If you haven't already, please hit subscribe, like, share with your friends. I'd love to hear your comments on old Montesas or vintage bikes in general. Please leave them down below. I'll try and get to as many as I can. And until next time, we'll see you later on the OSG Garage. Take it easy, everybody. Bye-bye.